Fantastic. Well, welcome everyone to our CAPER team colloquium. Tonight we have a fantastic speaker. Our speaker is Dr. Leilani Arthurs, who's an assistant professor of geology at the University of Nebraska, where she studies geocognition. Leilani has a long, rich history, and she's had a really hard time keeping a job, apparently, when you look at her resume, because her resume is really, really quite long. She has her PhD from University of Notre Dame. She grew up outside of Hilo, Hawaii, on the Big Island, which I know many of you have been to with our various teacher workshops. She worked at the Volcano Observatory while she was there, and she's got a lot of really interesting, diverse set of things that she's really good at in terms of doing geocognition education research. And tonight she's going to be telling us about her work related to student understandings of hurricane formation and how she used a grounded theory approach as her theoretical framework. So this is Leilani's first time she's used this particular video system, so if you have questions, feel free to interrupt her or to post them in the chat window. And with that, Leilani, I'm going to turn it right over to you. We're excited that you're here.
Okay, great. Well, thank you for having me, and thanks to everyone for joining the talk this evening. I'm really delighted to be joining you and to have a chance to chat about some of the research that I do. Like Tim said, I have a pretty broad background. In fact, I have 2 lines of research right now. One is in the area of environmental aqueous geochemistry, and the other one is in geoscience education and geocognition research. And so tonight, I'm going to talk a little bit about some of the active research that we're doing in the latter line. And where did the arrows go to go forward?
You do not see them anymore.
No.
I can move them forward for you. They're usually right next to the button that says Fit Page at the top, right above your screens. Oh, I know why you disappeared. I got to give them back to you. Stand by.
Okay.
Okay, you should have your button now.
Yes. Okay, I do. Thank you. All right. So the my talk will take about 35 minutes without questions, but feel free to ask questions because I've allotted time to answer questions either during and or after the talk itself. And Tim did tell me there's this chat box in the corner of my monitor where people might post questions, but I'll just let you know in advance. I may not see your question right away, and so it might get missed. So if that happens, please feel free to interrupt me or to save your question for later if I don't see it. In the meantime, the talk is divided up into the introduction, message, results and discussion, conclusion, and future work. So as we go on with the presentation, you'll see this image, and it's just intended to give you a sense of where we are in the talk. And so with that, we'll jump in with the introduction. Based on international rankings, the quality of STEM education at every grade level in the United States has been falling. And if you were to take a moment and imagine if you were in the position to improve the quality of STEM education, what might you do? So just take a moment to think about that. And some of you might have said in your mind you would choose a profession in teaching if you don't already have one. Or you might change the way you teach if you already do teach. Or you might decide to do research on teaching strategies, or you might choose to do research on student learning difficulties. And this is a really exciting place to be when it comes to discipline-based education research. So many of you are probably already familiar with the 2005 report rising above the gathering storm. So it's in this backdrop that discipline-based education research has been elevated in import. And if you've read it, then you'll know that these are some of the 4 key areas outlined in that report. And when it comes to what I do in terms of my geocognition and geoscience education research, I really am focusing at the university level science. And perhaps this is, I wasn't sure how much the audience would know, but DBER refers to education research in any academic area of expertise, really. But typically when we refer to it, we're thinking of STEM disciplines. And under the science and STEM, we have the physics, chemistry, biology, astronomy, and geoscience, and others as well. But these are really the main ones that I'm familiar with. And I live in the world of geoscience ed research. And so the geoscience education research that I'm involved in aims to characterize novice thinking and learning, and to find evidence-based strategies for developing student learning. Currently, I'm involved in 5 areas of active geoscience education research. One area deals with the impact of instructional technologies and interventions on student learning. So this includes maybe high-tech versus low-tech strategies. And so that includes clickers, but also homework and in-class activities, whether they're online or not. Student cognition and understanding of geological concepts, and student metacognition, especially with respect to developing their critical and scientific thinking skills. And the other 2 areas of active research that I'm involved in are student perceptions and attitudes about geology, learning geology, as well as faculty implementation of evidence-based instructional practices that facilitate learning. But for today, we'll focus on some of the research that's currently underway and fresh, not completely finished poking around and analyzing yet. And we'll look at an example on hurricane formation. And so the theoretical framework for this research, this whole line of research, is Constructivism, which is a theory of learning. And Constructivism emphasizes the essential role that the student plays in their own learning. Traditionally, instructors have embraced a transmissionist model of education, where the student represents an empty vessel waiting to be filled with the wisdom of their sage teacher, mainly via lecture. And so this is essentially the content knowledge of the professor or the teacher is transmitted to the student, who's an empty vessel. Constructivism, on the other hand, emphasizes the importance of students' prior knowledge and experience in either helping or hindering students in integrating new knowledge and developing skills. And so if we want to achieve deeper learning, we need to take into consideration students' prior knowledge and experience. And if we do that, then to achieve deep learning, we need to integrate students' prior knowledge and experience in the exchange between teacher knowledge and students' new knowledge. So there's a kind of dialogue between the teacher and students' prior knowledge, but as well as between the student self. So the student has a metacognitive type of dialogue confronting the new with the old, as it were, and trying to reconcile the new in the existing model that they're working with. So for the remainder of this talk, I'll refer to student prior knowledge and experience as conceptions. So when faculty and students understand what prior knowledge and experiences the students bring to the learning environment, then deep learning can be more effectively facilitated. So just by way of metaphor, imagine this network of roads. I don't know if you can see my cursor. Can you guys see my cursor?
No, we can't see your cursor. However,
you can't?
we can't see your cursor. However, there is a box that you can see that has a little star in it, which allows you to point to things. So, for example, there you go. You got it. That's it.
Okay. So thanks, Tim. So imagine you're looking at this network of roads here by metaphor.
We can't, all of a sudden we can't see it now.
Oh, you can't see it now? Oh.
Saw it a minute ago.
Can you see it now?
Yes, we can see that.
Can you see it?
Yep. Yes, we can see that just fine.
Okay, thank you. Okay, so imagine this network of roads represents a myriad different pathways that a student might take in thinking about a given concept. And your student comes to the class thinking about a concept at this point in the road. And your goal as the instructor is to take them to an understanding over here. But during the course of the semester, somehow the student takes a wrong turn and is headed in this direction. If you had had a better idea of the prior knowledge they came into the classroom with at this point, then you have a much better chance of more successfully directing them on the path that you had wanted to. So this is what I think of as trying to direct the students from, some understanding to that really aha moment, like, yeah, I really got that, because the instructor helped bridge what they already know with what they're trying to learn. And so this is really kind of the foundation for a lot of the geocognition research that I do. And so with respect to this particular study on hurricane formation, the objective was twofold. The first was exploratory in nature, and essentially it was to identify what are novice preconceptions or conceptions of hurricane formation. And the second part of the study was more hypothesis-driven. We had hypothesized that there were regional differences in how students think about hurricane formation. And so we wanted to test whether or not that would actually bear out. So how did we do this? We did this by way of a survey, and that survey was administered to 337 students. 169 of them were from Georgia, and 168 of them were from Nebraska. And in this table here, you can see the breakdown of the different courses from which students were surveyed. And in Georgia, we had a very large enrollment course that was surveyed. And in order to get a comparable number of participants from Nebraska, we had to survey 4 different courses. And we started with the most similar, environmental geology. We were able to get 67 students out of that course, which had 79 students enrolled in it. And then we went on to the physical geology courses and had smaller participation. And then finally, after capping those available courses, we went to an introductory level meteorology class to try and get some more students. So the survey was composed of a single open-ended question, and it had 2 parts. And this is the question as it was presented to the students on a piece of paper, essentially. And so imagine that question on a piece of paper, and that was the survey. And the survey was given to them prior to any instruction in hurricane formation. And if we look back at these courses here, all of the geology courses didn't really talk about anything atmospheric up until that point in the semester. So the students really had no exposure, no formal exposure through that course anyway, about hurricane formation or atmospheric phenomenon. The same thing cannot be said for the meteorology course. So even though they had not studied hurricane formation, they had been studying various other types of atmospheric processing. And so that had the potential to influence the responses, and we can talk more about that in a bit. So a mixed methods approach was used, and it integrated qualitative and quantitative methods. And so the first thing to do was to collect and transcribe the survey data. And so here is a collection of some of the surveys. This was just from one of the courses. And you can see the pile represents some of the binning, which is the next step here, to sort the similar bins. And so in this study, we actually sorted the data in preliminary bins and then transcribed them. But either way, some preliminary binning went on with the actual physical pieces of paper, and then the fine-tuning of binning, which you can see down here, then happened once they were transcribed in digital form. And so one thing to recognize is that this binning process is an iterative process, and through that process we developed the coding rubric. And so we can actually say that when we went into this study, we used a grounded theory approach because we had no predefined bins or categories. And so the categories that emerged for the codes were based on the qualitative data or the open responses. And we analyzed those open responses for themes and patterns. And it was based on those themes and patterns that we were able to identify distinct categories of responses. And those distinct categories then allowed us to apply some simple quantitative methods and say something more about all of this qualitative data. One thing that I should say at this point is that the coding that we did of the data was for the non-segmented data. So in other words, we coded the entire response based on what the students indicated were the primary initiators for hurricane formation. We do have segmented responses, so we were able to, pull apart the individual responses and look for different components in that, but we haven't finished analyzing all of that data. So tonight, I'm just going to talk about the non-segmented data. So as for the results and discussion, we had 25 different categories of conceptions that emerged. And just to give you a sense of what those categories look like, I did a screen capture of the spreadsheet. And in this part of the spreadsheet, you can see 9 of the different categories that emerged. Based on the 25 categories, so this list goes on down beyond what you can see here, these different categories could then be lumped together into bigger thematic descriptions. So for example, categories 1 through 4 comprise the thematic description that we call atmospheric bodies collide, meet, or mix. And so these 8 thematic descriptions are the ones that we're going to focus on for the talk tonight. I don't know if you guys want to read through some of these. They're pretty interesting. You can come back and look at them if you want. So the 8 thematic descriptions that we came up with include hurricane formation due to atmospheric bodies colliding, meeting, mixing, or combining or intermingling. Air or wind and water meeting, water currents meeting, and or the water moving in circles. So essentially here we have the water movement being the instigator of hurricane formation, which is really interesting, and we can look at some, we'll look at another slide later and talk a little bit more about that. They form due to moving air, strong winds, or storms, or they are storms. So this was a really more general kind of response, just with wind somehow being involved, or answering the question by just saying that they are a storm. And then this here, the hurricanes form due to differences in pressure, temperature, and or airflow. And then a little bit more specific, but also related to pressure, is that the hurricanes form when a low pressure area forms, or they form around a low pressure area. And the last 3, we have interactions with plate tectonics down here, and also the role of water, which is also a really interesting one here. And then the last one, they didn't really address the question. They might have written something down, but it didn't address the question, or they might have left the question blank. Okay, so if you recall from the, just lost my train of thought. From one of the previous slides, I showed you the question, and part of the question asked the students to draw and label a diagram to help them explain how hurricanes form. And actually having them do this was really, really useful in the coding process, because sometimes the words that they used didn't really, by themselves, give a clear picture as to what they were envisioning happening during hurricane formation. And so by way of using the diagrams to help explain their answer, we got further insight into what their thinking was. And so in this table here, I've summarized some of the drawings that are associated with each one of those major themes that we just looked at. And so with the first category, where we were looking at atmospheric bodies colliding or meeting with each other, you can see there are the arrows of clouds or swirling air or chaotic patterns going towards each other. And I really liked the drawing here. It's kind of hard to see, I think, on the screen, but it says boom. And this was not the only drawing where students had indicated, you know, like a collision of some sort causing an explosion. And in this picture, these are little stars. So kind of insinuating almost like the old cartoons, you know, where 2 people run into each other and then they have this stars kind of around their heads like, whoa, I just got hit. So they're not just thinking of a gentle kind of merging of colliding bodies. Some of them are thinking it's really something quite dramatic. With the second category, we have air or wind meeting water. And so you can see here the particular students that use this had the wind kind of blowing down towards the water. And then others had this swirl representing the air touching down on the water. And then others drew this. And this, you can see this type of drawing appeared elsewhere. It appeared in 1, 2, 3, 4, 5 different categories. So this was a really popular sketch for people to draw, and because it showed up in 5 different categories, this drawing in and of itself wouldn't necessarily be a good discriminator for trying to substantiate what student thinking is that falls into any particular category. It's not a good predictor. If a student were to just draw this, it's not a good predictor for what they think about hurricane formation. With this third thematic description here, this was interesting because this is the category where the students think hurricanes form as water currents meet or the water starts swirling. So here, I didn't include the labels in these drawings because I thought it would be too cluttered. But these 2 arrows here, this one headed towards the left bottom corner, and this arrow headed up towards the right upper hand corner. Those are 2 different currents of water, and you can see that the student imagines as those 2 currents of water pass each other, that passing of each other causes the water in between the 2 currents to start swirling. With this drawing here, these drawings here for category D, these are the different possibilities that students used, or I shouldn't say possibilities, the different representations that students used to illustrate moving air or strong wind. And the thing that's really notable about these particular representations is that all of them except for this one, are ones that you can see on the Weather Channel or on the weather forecast like AccuForecast and things like that. So students that included these, I suspect, but I don't know for sure, have had more exposure at the weather forecasting type of public media display. Let's see. Actually, one thing that would be worth following up on is to see how many of these representations came out of the meteorology course, the students in the meteorology course. Just thinking out loud here. Okay, and then for E here, this was the category where students said, well, there's some kind of difference in pressure or temperature in the atmosphere. It's kind of vague. It's not wrong, but it's very vague. And just as vague as the words are, so are the images, especially this one. Some students just drew squiggles on the paper. Let's see. And then F is the category where students associated hurricane formation with a low pressure zone. And so at the center of each one of these representations is the letter L, and they all wrote the letter L to indicate where low was. And so it's actually kind of interesting to see how the students represented the direction of air movement with respect to the low pressure area. Because here you have the air swirling in not a very specific way. But here you have arrows that indicate how the air is flowing towards the low, as you do here as well. And so here, the students represented arrows going straight in from a distance from the low, but then circling around it closer to the low. So there's some very intricate ideas of air movement encapsulated in this kind of representation. Category G was interesting to me because it is the category where, or the thematic description, where warm or moist air and water evaporation are involved, but also the uplift of liquid water. So some of the students included liquid water in it, and some students weren't clear as to whether or not it was a water vapor or water as a liquid. And so those that were specific in these first two, these are the kinds of responses that we got from students who imagined there was some water vapor coming off the ocean surface and then rising up. In these three representations here, the students described liquid water from the ocean surface being uplifted somehow. And so the students that drew this picture to me were the impetus behind me pursuing this particular question, actually, because I found it so intriguing. There were several students that imagined a hurricane being this swirling water tower. And it was just very fascinating. And I was kind of curious to pursue, well, what do other students think about that hurricane formation processing? In these two representations, the students imagined that the hurricane formed when you had large waves forming. And so we haven't finished trying to interpret what all of this means. As I said, this project's still underway. It's not finished yet. But I kind of wonder to what extent these types of thought processes about hurricane formation might be connected, I should say, to tsunamis. You know, so are the students in some way confusing the formation of hurricanes with tsunamis to some extent? Don't know. And we might not have enough information to answer that particular question through this study, but perhaps some follow-up questions.
Leilani, I got a quick question for you. I don't know if you could hear me or not. Hey, so what's the difference between B2 and G3?
This one and this one?
Yeah, how do you distinguish between them? Is it by the things they write?
Yes, exactly. So these drawings don't occur in isolation. They're part of the whole picture, the whole answer that they provide to that two-part question. And so here, students used this picture and described it as air touching down on water. But in this picture here, students that drew this kind of representation described it as a swirling pillar of water. That's the word that they used, the swirling pillar of water. Yeah, that's a good question, because these two representations are similar to these in the sense that they occur in multiple thematic descriptions. And so the way to distinguish them is from the text that they use to describe their idea about hurricane formation. Yeah, thanks for pointing that out. Any other questions at this point? Okay. And then with this last category here. This one is about plate tectonics. And the first time that I saw a response that associated plate tectonics with hurricane formation, honestly, I have to say that I thought the student was just pulling my leg because it was a student in my class. And I thought, oh, they're just being silly. But after surveying other classes, the response came up in other classes as well. So I thought, oh, this isn't just a student pulling my leg. Somehow they are thinking that plate tectonics is associated with hurricane formation. And so their drawings are less specific, but one can imagine, when I looked at these two drawings here, I imagine this is a map view or a bird's eye view of two plates moving towards each other. And then when I looked at this one, I imagined that the student was looking at it in a side view or a cross-sectional view. And there's one plate going under one while the other one is going over the other. Oh, and I should point out that these drawings that I've included in you guys hear me?
I
Okay.
can.
Okay, all right, great, thanks. So I'm not sure. I think I might have got disconnected when I was saying that. I wanted to make sure that I pointed out that the, let's see if I can get this star back. Maybe not. Okay. I wanted to point out that the sketches in this table are reconstructions of the student's original work. So these are not the student's original drawings. They're reconstructions of it so that they could be fit in the same table to scale and just fit essentially. But this is what they look like, as true to their real appearance as possible. Okay, so now that we've talked about the myriad different types of student ideas about hurricane formation that exist, you might be curious to know, well, how common were some of these ideas? And so if we look at the aggregated data for all of the students that were surveyed as part of this study, we can get this figure, this graph here. Over here I've included a short description of what each one of the themes were, just for your reference. So you can see that the notion that hurricanes form due to atmospheric bodies colliding was really the #1 most popular idea. And then the second most popular idea was that hurricanes form simply due to strong winds or moving winds. Then we had a range of different possibilities in here. And B, which I thought was an interesting response, was actually pretty well represented compared to the lesser represented theme. And B again is where air or wind meet the water. And let's see. So we did interquartile reliability comparisons. And what we got was 93% intercoder reliability when we coded the Georgia subset. And now, at this point, I should let you know that the initial coding rubric that was developed, recall I said that the coding was an iterative process. So the very first coding rubric that was designed was based off of the Georgia data set. And so once that rubric was designed and two people coded the data, they compared their data, they had 93% agreement in what they coded, which is actually pretty extraordinary. Okay, now when that same rubric was applied to the Nebraska subset of those 4 courses, the intercoder reliability was really quite variable. It was 48 to 93% depending on the course that was being coded. And so we went through an iterative process of redefining the coding rubric so that we could have higher intercoder reliability with the Nebraska data set as well. And so after we did that, we had 71% intercoder reliability. And this is prior to any discussion. Usually when intercoder reliability comparisons are made, the coders get together and then they talk about the discrepant responses and try to resolve the definitions that were used in the coding rubric and clarify the thinking that went behind that particular code. And typically that helps to increase the intercoder reliability and also better refine the coding rubric. So now if we want to ask ourselves, well, how about that hypothesis part of this study? You know, we hypothesized that there would be regional differences in ideas about how hurricanes form. So if we just aggregate the data by state, we do see some differences. And so most notable are in the B here and in E. And so if you recall, the thematic description or category, broad category, dealt with the air meeting the water. And this was most common, or I should say more popular, in Georgia than it was in Nebraska. And if we look at E, then we see that E again is the hurricanes are forming due to pressure and temperature differences. We see that students in Nebraska are almost twice as likely to say that than students in Georgia were. So these are two pretty distinct differences, and I thought it was kind of interesting because the students in Georgia that were surveyed lived less than an hour away from the coast, so they have more experience with regional settings with open water. And the students in Nebraska are really familiar with the tornadoes that happen and very acutely attuned to atmospheric phenomena in that sense. In fact, many of our students here in Nebraska are storm chasers or tornado chasers. So I had mentioned to you before that of the students that were surveyed in Nebraska, some percentage of them came from a meteorology course. And so when I was going through this data, I wondered to myself, is this response that we're getting here from Nebraska students an artifact of the students in the meteorology course, which had been learning about pressure and temperature and atmospheric processes in their course, even if they weren't directly related to hurricane formation. And so what I did was I did a chi-square analysis with and without that course. And the chi-square analysis produced really similar results both times. And in both instances, the results indicate that the differences really are significant. And so in this plot, I decided to show all of the student data, including the students from the meteorology course. Okay, so this study essentially achieved what we were hoping to achieve. We concluded that there actually is a wide range of novice ideas. As I mentioned before, there were 25 different categories of responses and 8 major themes that emerged. And the study also provides evidence that there really are regional differences in student conceptions about how hurricanes form. That doesn't mean it's the end-all be-all, but there's certainly the data does suggest that there are these regional differences. In terms of implications, if we assume that these regional differences are real, then one of the important implications is that when it comes to instruction, we may need to consider more type of regional sensitivity, as it were. Regional sensitivity in the sense that we want to be attuned to how the region from which our students come may be influencing how they think about key geological concepts, and in this case it was hurricane formation. Also an important implication is that this study provides yet additional evidence, as prior research has done by other people, the need to integrate these student conceptions appropriately into both instructional approaches and strategies, as well as the design of assessments of student learning. And as for future work, we still have some interpretation of the non-segmented data to do, and then we also need to finish analyzing our segmented data, and we would like to then use this information that we've obtained to develop both instructional and assessment materials that will help students better understand how hurricanes form by integrating some of the ideas that are popular about about hurricane formation. And so with that, I'd like to acknowledge Georgia Southern University and the University of Nebraska-Lincoln for their support of this line of research, as well as all of the students that participated in the survey, and my colleague who has so generously spent his time to do some of this intercoder activity. So with that, I'd like to thank you for your time, and I'd be happy to answer any questions that some of you may have. I saw a question that said, are the students from, where did it go? Are the students actually from these respective areas? Yeah, that's a really good question. And so more than 90% of the students in each of the courses are residents of either Nebraska or Georgia. And so we were able to get that data from other sources, not by the survey. Yeah, the data, so someone said the more disaggregation of the data can provide more insight. So the 25 different categories are the more disaggregated data that we have. We did not collect gender data for this study, so we wouldn't be able to say that women versus men are more apt to think one way or the other about hurricane formation, mainly because the question that we were asking was really looking more at the potential regional differences, not gender differences. But that would be an area for future study if someone was interested in pursuing that. What percent transfer from, what is OOS?
And feel free to use your microphone if you like.
Sure, I'll give this a shot. I would think there'd be a lot of difference in the kids in Statesboro between kids who transferred in from Atlanta versus kids from Savannah in terms of how they grew up with hurricanes and how they were taught about them as, say, grade school kids, you know?
Yeah, that's possible. We didn't really survey the students to find out what kind of formal instruction they might have had on hurricane formation, but they certainly do have more experience with hurricanes. And in the course that was surveyed in Georgia, many students actually said that they had lived through one or more hurricanes. So they had firsthand experience with this particular phenomenon. Okay, what do you do if their writing doesn't match the sketches they make? We didn't really have that situation. So I guess if we had that situation, we would probably just not count it because it would be kind of schizophrenic, so we wouldn't know how to deal with it. Oh, OOS, out of state. Okay, thank you. Yeah, we did have some out-of-state students in the courses. As I said, there were less than 10% of the students were out of state, but they were in there, and we didn't ask for their zip codes in this study. We're doing another study similar to this, but with tornado formation, and we are asking for zip codes. So we'll get a finer grained sense of where the students are coming from within the state. Yeah, I had wondered about that question. Tim wrote, why do you think the intercoder reliability was so weak in Nebraska? So it's the same two people coding the data between the Georgia and the Nebraska data set. And so I too was puzzled by the low intercoder reliability with the Nebraska data set. But as I said, there was a range from something like 40 to 90%. So with those 4 courses, some of the courses were rated really high and some were rated really low. And the course that was rated the lowest was actually the meteorology course. And I think the reason for that is because the students in the meteorology course were using language that had not been accounted for when the initial coding rubric was developed using the Georgia data set. So they were using language like low pressure, atmospheric waves, other types of language that we weren't seeing in the Georgia data set. And so when we refined the rubric, then we created categories that were possible to actually bin the Nebraska student responses that were like that into. So in other words, the original coding rubric didn't really have an appropriate bin for some of the Nebraska student responses. And so that's part and parcel why the intercoder reliability was so low on that first pass over. But as I said, creating a good rubric is an iterative process. So if we were only looking at Georgia students, it would have been a great rubric. But we wanted the rubric to also apply to student responses in Nebraska, so it needed some revision.
Dr. Arthurs, this was absolutely fantastic. Thank you so much for sharing your work with us. And we tell you you've got a lot more stuff that you're trying to figure out and how it all fits together. And there's been very little work on formation of hurricanes and storms and inclement weather in general. And we think this is a great first step. And we really appreciate you taking your time to share with us your expertise on this. Thank you very, very much.